recording at this point. Please note that the recording will be stored on the NEHA LMS as well as the Private Water Network Resource Hub. And I've already mentioned this, but I do want to mention it again, is this workshop offers up to 3 continuing education credits. We will be hosting 2 follow-up learning sessions. The first one is scheduled for November 9th at 1 p.m. Eastern, and the second one is scheduled for January 25th at 1 p.m. Eastern. And all registrants are open to attending the learning sessions. There will be a survey towards the end of this workshop. Please do take that survey because it helps us in planning for future trainings. And with that, I will turn it over to Dr. Barrett.
All right, I'm going to share my screen here. Thank you, Reem. Share. All right, can everybody see?
Yep.
Good. All right, Reem, I'm starting my time. All right, so hey, everybody, it's great to be here. I appreciate you all having us. As Reem said, we're going to be talking about impacts of climate change on private drinking water wells. When we started these discussions with Reem, I guess several months back, one of the things that kind of sat on me was, how do we want to, really frame this? Because this is a very timely topic that to me is not going away. So one of the things you'll notice today, and what I've tried to do is, first of all, to me, we want to set a baseline of like what exists with private wells now, because if we ever want to talk about an impact, where did we start? That impact may be where are we looking at, or what do we potentially see in the future? So there are a lot of assumptions, that we can make along the way, and I would encourage any of y'all, I know there's going to be time at the end, take some notes if you've got some questions to come back to, why certain things were presented. And why I showed them in a certain way. But again, I'll try to hit those along the way of the presentation. But if you do have any questions, please just jot them down. We'll address them towards the end. So again, as Reem said, I'm Jason Barrett with the Water Resources Research Institute here at Mississippi State University. Wrapping up 17 years, been addressing water and wastewater and private wells the entire time that I've been here. So, am I moving? All right, so I'm going to go over our outline. I'm going to just kind of look at the population data so you'll see where we are in Mississippi, just to understand what we're looking at. And I'm going to say most states you could do this exact same thing for your state. And some of you can find some national models that are already out there. I may touch on a couple of resources that we've created over the years just to try to help. And then go through kind of our workshops of how we interact with private well owners. And then what I'm going to show you is the last couple of years of sample data that we've got, and I'll talk through that. And then last time we get to some projects we've touched on, to me, that are when we start making the assumptions of climate change and what are those and what are the impacts, or maybe what are the examples of climate change and how we're seeing them and how they impact those private wells. So private well data, when we look at Mississippi, when we look at Mississippi, it's not consistent across the state as far as private wells in every single county. We've got a very robust number of public water supplies across the state. If anybody has ever seen the University of Wisconsin's cooperative map, we've got more co-ops, rural water co-ops per capita than any other state in the nation. So with that, you would think we would have no private wells, but strangely enough, we do. We're still in about that 11 to 12% range. But when we did our breakdown and the data that we pulled and compiled from multiple sources to get a really accurate number on private wells, because as all of y'all are probably aware, nobody is asking that question on a, even the U.S. Census does not ask about specifically private wells. So you really have to take some deductive reasoning to find your private well owners across the country. So from everything we've been able to see, we've got about 63 counties that actually have private well owners. Now, we all know there are probably private well owners in those other 19, just based on our data, we don't have it. We have 25 counties that have from 1 to 300. And then we have 26 that have from 1 to 3,000. We have 26 from 3,000 to 10,000. Then we have 12 from 10,000 or more. So if you look at this colored map, you'll notice North Mississippi, and this is just shy of a big metropolitan area called Memphis, Tennessee. Very large airport, but also you see it's just a lot of people live and work in Memphis, but who work in Memphis but live in North Mississippi there. And one of the things you see is a lot of these people buy land in rural areas that our public water supplies just have not expanded their system to yet. So as a result, people put down private wells. And then same you see here in the central, our capital city is here in Hinds County. Very similar. A lot of people move, outside the capital city to move into these rural parts. Again, sadly, our rural associations or our water utilities have not expanded out, and people end up drilling private wells. And then here on the Mississippi Gulf Coast, sadly enough, because we had millions, if not billions of dollars pumped in post-Katrina to build these large utility districts to serve these entire counties. Yet sadly, we still have a lot of people on private wells in those lower counties, and they hold the largest populations of our state are housed in these lower 6 counties. All right. So looking here, and I pulled this together, and if you'll notice, we've got 1970, 1980, 1990. Those were the last 3 census years that the U.S. Census asked the question related to private wells. And if you see here, we had this ticking up of percentage of people on community water systems. And you would hope 1960s, 1970s, a lot of y'all may be aware, was when the old farmer's home pumped out a lot of money, and we were building and creating these community water systems, trying to get people on a clean, safe supply of drinking water. And 1990 was the last year. And the assumption that we've been given is that they were thinking, or they were assuming, that every new customer or every new citizen would be on the community system. But we're not seeing that, because see here in Mississippi, we've seen a barely a tick down from then. We still have the same pretty much population on private wells. And just, from what we see and what we work with as far as private well owners in Mississippi, it is a wide open business. It's a good business for people to be in. Sadly, it's not regulated at this point at all, and I'm not necessarily pushing for that, but a private homeowner can simply call a well driller, and as long as the casing is below 6 inches, which most of them are 4 inches in Mississippi, they don't have to pull a permit. The well driller can drill the well, and they're supposed to be following drilling codes, which again, everyone we've seen, they do. Some of the older ones, I may question that, but in the last 15 years, they seem to be all done right. But as long as they're following drilling codes, they can put it in and get down the road. But then we start getting into our issues, because a lot of these homeowners are not fully aware of what they have, how to maintain them, how to keep them up. So that brings us into where we are here. This is an example. Early on, when we started doing the Mississippi Well Owner Network, and again, y'all have Joel Pigg talking on here later. We borrowed a lot of resources from Texas A&M, the Texas Well Owner Network, Virginia Tech, the Penn State, Pennsylvania Well Owner Network. So we created some how-to videos, how to sample your well, some best practices here, because one of the things we were seeing is that a lot of our sample results may have been negative, or let me say positive for total coliform. And a lot of it was sampling error. So again, we created a how-to video on how to properly collect a water sample. And again, these are all publicly available online. And then even from our states that have started up private well programs, Florida, Auburn. You know, we opened them up because, again, when I started a decade ago, Texas, Virginia Tech, Penn State, they were all very open to allow us to share. So if any of y'all have interest, you know, y'all look, because those states, we've been doing this for a while. A lot of us are collecting a lot of the same survey data, providing the same information out, trying to be just a good resource across the country. Okay, this is another thing we put together, because when I was starting this, there was no visual, and I'm a very visual person. There was no visual for drilling codes at all. So I put this together for our well owners. The main things I like to draw or talk about this septic tank and the setback distances that we have. I mean, I know we have 50, you know, I would encourage people to do a lot more than that. And then when we talk about our minimum for annular cement, this bentonite clay should be 10. You know, if you're potentially close to a contaminant source, it should be 50. Also, when we think about this 12 inches above ground surface, this is one of those pieces that I'll talk about in a minute when we look at our climate effect. But anyway, I like this visual so we can start sharing this with customers, so they start putting an image together of what is there instead of just that white pipe sticking out of the ground. What do we have below that? What is it connected to? Thinking about these distances. All right, so thinking about workshops, when we created the Mississippi Well Owner Network, again, I didn't come up with this all by myself. Texas already had T1, Texas Well Owner Network. Virginia Tech had their program, Penn State had their program, and they just let me come alongside of them and just follow along. There's another great guy, Steve Wilson, at the private well class. Huge asset. I really enjoyed and appreciate Steve for all he's done all along the way. And I would encourage any of y'all, if you have any questions related to private wells, check out privatewellclass. I think it's .com or .org, but Steve Wilson, University of Illinois, Urbana, great program, great class. And again, that website's full of content, full of information. I always point people that way. So the last couple of years here, this is where we're going to kind of, the road meets the road. The last couple of years, I pulled data the last 2 years. So what do we wrap up? FY 23. So 22, 23, we screened 832 wells. And again, I've got a pie chart to show this. As I said, for y'all, I'm a visual, but we're seeing very consistent numbers just like this. 66, or you could say 67% absent or clear of bacteria, and then 33% present. So this is 33%. So rough numbers, 1 in 3 wells that we screen have total coliform bacteria present. That's not good. And it's amazing to me, because I also deal with public water supplies. It's amazing to me when we look at public water supply numbers, and where this is 33 for private wells, it's usually in the 0.01, if not less, for public supplies. Yet more people seem to have a higher trust in their private wells and a higher distrust in public water supplies. So it's amazing to me that it's out there. But again, this is what we're seeing year in and year out. And, you know, I've almost gotten it. We've done enough workshops, and usually if I'm getting 20 samples or more, I can just about tell you 1 in a third are going to be total coliform present. So again, we're just seeing it's just a very consistent trend. And to me, 1 in 3 is not enough to give me comfort. All right, so let me jump into some demographics of what we're seeing. And one of the things that does, and I'll go ahead and jump to this here. One of the things that it does tell me, I know we have some assumptions we can make, because we're doing our workshops through our extension programs, through our extension county offices. I mean, that's how we do. That's how we work. We have specialists, and we work through our county offices. So again, one of the notes to have on this is that these demographics are based off of interactions with a county extension office. Now, again, we always open them up. You know, we will have a press releases that go out in the mail. We will actually have social media graphics that go out as well. And we open these up to the public. And interestingly enough, I don't have it listed in here, but you know, early on when we had no funding for the program and we were charging, you know, we had greater participation in our workshops versus when we were getting some funding and we would offer some of these workshops for the sampling for free versus having to charge for the sample. It's really strange. But anyway, last couple of years, just looking at the breakdown, you're starting to see very similar kind of aging out, 2 people per household, male, female breaks, very similar. I would draw your attention to this here, looking at the percentage of people that are over 50 that are attending our workshops. So we're almost at 60, 79, 69, almost 70% of our participants are over 50 years old. And then when we look at our level of education, you look here at our college graduate, that's 42% of our participants are college graduates. And you'll see in a second when I compare to our state numbers. And then also looking at our racial profile, you see 91% of the people that are participating with our workshops and our sampling are white, whereas 7% are African American. All right, so I'm just throwing this out there. The kind of the notable demographics from the well owners themselves, about 52% are male, age 69%, 51 and older. Education, I stated this, 42% are college graduates, 91% are white. I'm gonna put this in some pie charts so we can see it a little clearer. So this is our age breakdown. So it's one thing to just see a number, but when we start seeing it actually in a pie chart, you start seeing the magnitude of respondents. Now, a couple of assumptions you can make here, you know, probably the largest one that I make is you're seeing a lot of older people who are retiring and they're moving into rural areas to build a home, and they get out there and they realize there's no public supply, so they end up drilling a well. Also, when we think about workshops, a lot of our older people are the ones that may not be working, they may not have kids in the home, and they can spend an afternoon, you know, after 5 o'clock in an extension office participating in a workshop. So we look at our education breakdown. So we look at the post-college, college grad, some college, high school grad. So if you start here at high school grad, you look at the percentage. I mean, let me go. You look at, if you start here at high school grad and go around, this is a very large percentage of our well owners are high school graduates and above. And again, you'll see this when I compare it to our state numbers to see where we line up. All right, and again, from the racial breakdown, as I told you, I like the pie charts because you can see the magnitude of it. But again, looking at the breakdown, 91% white, 6 or 7% African American. All right, so when we compare to Mississippi stats, this is one of the things that I would like for us to do a little bit better job on, because when we think about, are we meeting the needs, or are we truly meeting the representative needs of Mississippians? All right, so here, high school grad or higher, from the well workshops, we're at 87%. From Mississippi stats, we're at 85.6. So we're pretty close there. And then when we start looking at bachelor's degrees or higher, well owners at 42%, the state average is 23.2. So we're a good 20% higher there. Now, at the same time, you know, one assumption you could make is that those bachelor's degrees or higher are the ones with the private wells. All right. Another, when we look at the racial breakdown, so we look at white well owners is 91%, Mississippi's 59%, African Americans 7% for well owners that are participating, whereas the state we're at 38%. So again, one of the things I want to draw out is this is not necessarily saying that equal representation of people in Mississippi have wells. So we don't need to fall into that false narrative. If anything, I think we're a little off, and I've said this at presentations before. when we start thinking about, lately, the last several years you've seen with proposals and projects coming out where we're trying to focus efforts, we want to look at the underserved communities. Well, I don't think we should just easily just put private well as underserved people. If anything, to me, the underserved areas that we may see in Mississippi are folks that are on a public supply of water, but are actually on septic tanks. So we've got about 12% on private wells, but we've got about 35% on septic. So we're doing we have a real lack of public supply of wastewater treatment in Mississippi. So to me, that margin is more of your underserved, and that's more related to wastewater, not what we're dealing with today. All right, moving on. So now let's look at some private well characteristics. What we're seeing here, average depth of wells we're seeing is about 240 foot deep. Average age is about 26 years. And one of the things that's interesting to me, because 240 foot is, and a lot of y'all may already know this, in well drilling depth is really not that deep. But a lot of people, just the lay consumer, may assume that that's really deep. And then at the same time, not realizing how that well that was originally drilled is a direct conduit, regardless of the fact that it's 240 foot deep. Something can get contaminated real quick just because of that one conduit connection. Look here, you'll see, which doesn't surprise you, 90% of our people participating are using it for domestic use, which makes perfect sense. Most of them are drilled. I've seen a few of the old dug and bored, and they all have bacteria. They're not in good shape at all. I haven't seen anybody necessarily using it for drinking water, but they seem to still have them on their place. And then I would say here, most of the folks that Mark don't know, it's usually a drilled well. They're just not familiar with what they're looking at. And that's not a problem. It's just, that's why we ask them to report. All right. Another big sign here, when we look at treatment devices, you notice here 81% have none. They have no treatment device at all. The largest that you see is an actual sediment filter. And I would say you probably see this because most people just assume a filter is a filter. And one of the conversations that I have so many times, people call, they have total coliform bacteria, and they say, well, I went and bought a filter and I still have total coliform bacteria. And you have to ask, what type of filter did you buy? And they end up buying a sediment filter. So as you have to explain to people, filters are only as good as what you're actually filtering for. So if you're filtering for sediment, don't expect it to remove bacteria. If you're filtering for lead, don't expect it to remove iron. I mean, I'm just thinking about different or copper. I mean, just thinking about different components that you may be trying to filter out. But again, the lay consumer just assumes a filter is a filter. Let's go get one. We're all clean and clear. And that's not necessarily the case. So you have to talk to consumers about the different filters and different devices that are out there. All right, next, when we ask about acreage, so we're just trying to look at where are people living. A majority of folks that you see here are on properties less than 10 acres, and usually it's just a lot, an acre or two. 34% are 10 or more acres, and then farmer ranch, 13%. All right, so just some characteristics to jump at, and again, I'll go through some pie charts as well. Average well age 26 years, and we've seen this go up. I've noticed this over the years as we've kind of compiled data. It seems to be that we're getting more people that have older wells that are finally coming in and getting things tested. And it's so interesting to me because they'll say, I've had this well since it was drilled. This is the first time I've ever had it screened. And then the next question is, well, how often should I do this? So I always tell them, the baseline, I would do it at least once a year, unless you noticed a difference in taste, color, appearance, smell. But then I also say, public water supplies pull bacteriologicals once a month. So, you know, if you want to do it once a month, great. At a minimum, I do it once a year unless you notice those differences. So primary use is domestic. Well types, as we got 74% drilled, but I would say that's going to be 80, 89, 93% are more likely drilled from what we see. 81% no treatment devices, 9% sediment filters. So getting into the pie chart, just so we start seeing the magnitudes, what I like. So primary well use, 90%, 91% domestic household use. All right. When we look at well types, drilled, and just I guess to get into that for a second, the drilled method is a lot, I'm gonna say a lot cleaner, safer from a water quality standpoint, just because it's got the precise borehole. They're able to backfill with that bentonite clay around the casing just to seal it off well. So highly recommend that. You know, we've seen some of these shallow, old, dug wells and we've pulled some samples from those, and they almost all come back with E. coli, not only total coliform. So, okay, moving. All right, sediment filters again, or any type of treatment. We've got none on here. I'm a huge advocate if somebody wants a private well and they say, well, how do I make it? Safe? You know, to me, if you do put a sediment filter on it, put a sediment filter close to your well. I think that's fantastic. And if you can, UV is about the only thing I've seen, or let me say, only thing I like that's a small volume that will treat or potentially treat for bacteriological at a household level. So a sediment filter and small UV, I think you could run great with private wells. All right, so primary residence type, again, you're looking at 45% of these rural properties smaller than 10 acres, 34% is farm and ranch, 10 to 100 acres, and then 12% is farm and ranch, 100 acres or more. So this is the bulk of the people that we're seeing, because just about no one else is going to be in a city with a private well, because most cities don't allow, or most cities and towns don't allow private wells drilled in them. All right, so some assumptions that we can kind of make from the data that you're seeing here, and again, we can talk about this when we'll get in our discussion time, but you know, younger generations seem to be a little more urban than rural. When we look at who's in the counties and who are the private well owners, we're seeing a younger generation. Seem to be a little bit higher socioeconomic status of people that can afford these private wells. You know, about the cheapest you can get a well drilled in Mississippi is about $5,500, $6,000. And that's if they can hit good water, fairly shallow, and they're just setting you a pressure tank, running the line, and then you connecting it from there. Also, private well owners are less by desire and becoming more by necessity, which you heard me talk about people moving into these rural areas and then needing a water supply. But I will say this, there are people, and we meet them, that say they want to be on their own water supply. They don't want to be on a public supply. They don't want to deal with that. They want to have their own supply, and that's their prerogative. And that's, to me, the arguing side of why private wells are unregulated. You know, we have that autonomy, that freedom. So, all right. So what is this telling us? You know, to me, if you're on a community water system, be appreciative of that available drinking water supply. I'm a huge community water system advocate. Even though we do a lot of education about private wells, I'm really a huge advocate for safe drinking water, but just realizing the different options that are out there. People are willing to pay for quality drinking water, so community water systems need to make the effort to get to water people within their certificated area. I think a lot of our community systems over the years have just done a very poor job of really expanding and getting out. And a lot of it is because we've kept rates too low for too long. So majority of the people across the country just expect public water supplies to operate off pennies, and that's just not really viable, and we're seeing that. because, you know, as most of y'all have seen, the federal government's had to pump out billions of dollars just to try to prop up a lot of these public water supplies, because again, we haven't charged adequately over the decades. Also, if you're on a private well, do not simply assume that your water is safe to drink. Have your water screened at least annually. Educate yourself about a private well. This is one of the things I really like doing. I really like getting into the field with homeowners and talking through what they have, how to keep it safe, how to I'm gonna say kind of implement best practices around it. We have a lot of wells in the state of Mississippi with zero wellhead protection. There's no concrete slab, there's no shed, there's no building, there's nothing. So again, just helping them out in that regard. All right, so we talk about that piece. So I wanted y'all to understand kind of a baseline of where we see our well owners as well as our wells right now. So when we think about how climate change may impact private well owners, I'm going to touch on a project we were connected with. This was, and Joel Pick is going to speak next. Joel did some of this after, or I know Texas Well Owner Network had a connection with this after Harvey. You know, we had some connection with it after Ida, where we're actually testing private drinking water wells before and after. We're just seeing the impact of these floodwaters on our wells. All right. So when we think about private wells, again, here's just an example. And this is one of those where you're in a proximity that's getting a lot of exposure to potentially a lot of things that you may not want. So anyway, private wells are major drinking water sources. As I just talked about, they're not regulated. Maintenance and monitoring may be challenging, or they can be challenging, mainly because they're the sole responsibility of the well owner. And they're vulnerable to disturbances, which we are aware of that. All right, so let's hit this real quick. It's just kind of a visual of what's happening to a private well during a flood. So we look at the kind of the ground level here. Then we talk about the floodwaters coming in, getting into our casing, potentially getting down to our groundwater supply, getting down to our pump, and this is just going to start recirculating. All right, so here's some pics. So post flood. So again, this here is actually that's our booster pump coming off. But if you notice from this mud and everything in this picture, this was covered. So this was inundated. This was 7 feet over the well. So these floodwaters are simply inundating the well casing, they're inundating the well shaft, they're inundating the water column there. All right, so this is after the flooding. Yeah, I'm gonna hit that. So pathways like this exist. So beliefs that water is safe because wells did. Y'all heard me mention that earlier. Some people just assume that their well water is safe because it's deep, and that's not always the case, because when you get a flood water above, I mean, it is, again, it's a direct conduit. It can't, if there's a pathway for it to get in. And if you notice here on the bottom, you see this pressure tank is actually knocked over, casing is exposed. I mean, so this is a prime example to where we're going to get inundation. All right, so touching on this Harvey study, again, as I mentioned, Texas Well Owner Network here, we're looking at here as far as who was evacuated related to voluntary evacuation or mandatory evacuation. All right, so there were a lot of samples, as you can see, over 8,000 samples were collected during this time for this study. All right, so this is what I want to hit. I'm gonna go ahead and hit here. So let me go back. I'll move forward. I'm gonna go back. All right, so you look here. So when we think about what we were seeing as far as total coliform percentage of samples, you heard me show some Mississippi numbers earlier where we get about 33% total coliform. And we're not near at 12% with E. coli, we're lower. So here, when you look at these pre-flood numbers of total coliform and E. coli, so again, this is where we want to draw the baseline of like, what are we seeing? So I already showed you what we see in Mississippi. So here's an example of Texas. Again, you're seeing a very similar number in this 33%. It's pretty odd, but I think they're highly correlated because we're also seeing it in Virginia and Pennsylvania, Florida. We're seeing them. All right, so this is pre-flood numbers versus post-flood numbers. So you're seeing 33% to 46, 3% to 12. This is the scarier number to me because we all know coliform is an indicator bacteria. E. coli is the serious threat. All right, so this is with residents that reported their wellheads were submerged or not submerged. So even look here, this one was not submerged. There was a small tick up, so maybe from 33 to 37 versus submerged that went to 56. So again, these are knowing that it was submerged, and look at the E. coli jump. So when we're getting, and to me, this is like the drive home point here. If we are having climate change, if we're having a climate impact and we're having these excessive storms that are creating massive floodings, if we're having any type of tidal issues that are inundating our wells, this is clear data that we're seeing. And again, we've repeated this in another state I'm going to show you in a second, where if these wells get inundated, and they don't necessarily have to be submerged, but once they are submerged, we're showing with high confidence that we're seeing a tick up in total coliform. We're seeing a tick up in E. coli. So as y'all heard me talk about earlier, the graphic that we did where the well casing is only 12 inches. So 12 inches is the minimum code, minimum standard for well drilling. So that's where people try to go. But we could go higher if we needed to. All right, so here, this is just some of the private well programs that we're participating in that. When I was telling you we participated in IDA, in Mississippi, we did some post-IDA well testing again. That was the hurricane that came through, flooded a lot of South Mississippi. So from that, we were looking at how many private well owners are impacted by flooding, what are potential modes of floodwater well connectivity. So when we look at, I'm going to drop in here. So this is, again, talking about the private well model. So number of well users that we have in these counties that are there. And if you look, these high density areas, so impacted by floodwaters, we're able to see who is potentially impacted or the magnitude that's potentially impacted. So how many people rely on private wells? I think I'm going to hit one more. Okay, so yeah, we're looking at the kind of the large numbers. North Carolina is really high, Alabama here. So 9.4 million people rely on well water along the Gulf and southeastern coastal areas. All right, so how many private well owners live in flood zones? So this is, again, I guess we could make that or just everybody may make that assumption already with Florida. When we look at the flood prone areas, so Florida and Alabama, again, kind of where they match up. So we have 1.1 million private well owners live in flood zones along the Gulf and southeastern coast. Okay, so what portion of private well owners live in flood zones? So now we have 1 in 9 private well owners live in flood zones along the southeastern coast. So when we think about these events, the Harveys, the Idas, I mean, when we've got confident data like this, and we know that 1 in 9 private well owners, we know we have 9.1 million that live down there that can be impacted. 1 in 9 live in a flood zone. So we know these numbers, we know the impacts. It's a matter of what are we going to do. So, and I'm going to even look at the county level. You start looking at private well users at the county scale. So we're seeing what is potentially impacted. All right, so what's happening to our private wells? I'm just talking about this as kind of a repeat. A repeat of what we're seeing here. So when we think about, I like this graphic just because looking at the Gulf Coast region, we already know, we're currently in the hurricane season now. We think about the potential impact to our homeowners, to our private well users. We already know there's a massive amount of people. What are the things that we can do? Because I'm going to say that's our responsibility. we know that we're having climate change impacts across the country. We know that we have massive amounts of well users, and we know that the results of that can be excessive levels of total coliform, excessive levels of E. coli. So what are the things that we could do from a policy side, from a construction side? Those are the next steps. All right, so just, I'm gonna say, summarizing, kind of recapping that, 9.4 million people live or in the Gulf region and rely on private wells. 1 in 9 well owners live actually in a flood zone within there, and there is connectivity between well water and flood waters, and we're seeing that. I'm gonna leave my contact there. Reem, I'm right at 40 minutes.
All right. Thank you so much, Dr. Barrett. That was a great presentation. Folks, please feel free to use the chat box or the Q&A box to drop your questions. We'll take about a couple of minutes to answer some questions for Dr.
You want me to stop sharing here?
Yes, please. And I see, Jason, we've got one question in the Q&A box. I'll read it out. The person asks, do you feel that the subset of wells that you sample is representative of the wells out there? And they're particularly referring to the 1 in 3 with total coliform contamination.
Do you want me to type, or do you just want me to verbalize?
You can you say it out loud. Yep.
Okay. Okay, so the question is, do I feel that the subset of wells that we have, the 1 in 3, is representative of total coliform contamination? I'm going to say no. I'm going to say it's probably higher than that. And my assumption is the people that are coming to well water workshops are the ones that care, and the ones that are wanting to try to make some form of improvement to their system. So I think there are a lot of wells out there that are very low maintenance, if any, and then you have just this level of just unknowing. So I think it would probably be a little bit higher, maybe in the 40 range, if we were able to take a snapshot of every private well in the state of Mississippi and sample them. I think we would be much higher, because again, you know, the people that are attending the workshops, in my opinion, are the ones that are wanting better quality water, and they know they need to do something. So I think there's a level of just unknowing out there that may be the reason that number would be higher.
Great, thank you. Chris asks, have you seen any negative sentiment from the or for the community water system since water crisis that happened in Jackson recently?
What is this? So have you seen any negative sentiment for community water systems since the water crisis that happened in the Jackson? Yeah, you know, I would say there has been across, and you know, I've done a lot of interviews and with folks, and I've tried to explain, or at least in my educated
Perhaps he got disconnected. Jason, are you with us? All right. We will hold questions for Jason until the discussion session. It looks like he may be struggling with his connection, or maybe he's back on. Jason, are you back on?
What happened to me there?
I think you might have lost connection just for the time being.
Yeah, I was talking away. Yeah, if you will, I'll finish my statement there. Do I think that the sentiments have soured a little from Jackson? Possibly, but I would say this, you know, we've got a lot of very well run water supplies in the state of Mississippi. So again, I think if anything, there may have been some folks that have turned to private wells for a lack of trust in community water system, which is kind of a sad case. Because I think community water systems are the way to go. But I do think it's not as bad as the assumption may be, because again, we've got so many public water supplies in the state of Mississippi that are very well-run systems. So.
Thank you so much, Jason. Appreciate it. At this point, we will move on to session 2. If you do have some more questions for Dr. Barrett, we can take additional questions during the discussion time. With that, I will hand it off to you, Joel.
All right, thank you very much. And I think I am sharing the screen.
Not yet.
Not yet.
Oh, I see it popping on. And I see it. Perfect.
Okay, so it's in the right display mode. That's always gets me.
Yes, it is.
All right, thank you so much. All right, folks, thanks for being here this afternoon or this morning, as the case may be. I guess we're afternoon everywhere now, maybe. The talk that they've asked me to present is groundwater depletion as a result of climate change. So we're going to get into that here shortly. Okay, and just to kind of a brief, I know Reem gave us a introduction a while ago, but just to kind of tell you who I am and what I do. I am an extension program specialist with Texas A&M AgriLife Extension, part of the Texas A&M system. Since 2019, I've been the program coordinator for the Texas Well Owner Network that Jason has kind of alluded to a little bit there. Thank you for the plug, Jason. Prior to that, I worked for the Real Edwards Conservation and Reclamation District, serving as the general manager from about 2011 to 2019, which is a private or a small governmental department that is over the 2 counties of Real County and Edwards County in Texas. We've tasked with dealing with groundwater issues within those 2 counties. Just to kind of go along with that, there are 254 counties in the state of Texas. Jason said there's 60 some odd in Mississippi, so we've got a few more than they do there in Mississippi. Out of the 254 counties we have in Texas, there are 99 groundwater districts that cover about 2/3 of the counties. So there are some counties that do not have groundwater regulations or do not have a district that covers them, regulates them. So it can be a free-for-all in those counties. Prior to working for the groundwater district, I did serve as the extension agent for Real County out. And I don't know if anybody knows where Real County's at in this discussion, but I know everybody's heard of Uvalde after the shooting incident they had there year before last. So I was about 60 miles north of where Uvalde's at in the far western side of the hill country of Texas. Prior to that, I did serve as a program specialist here at Texas A&M on campus with cotton and peanuts, serving the whole state with that project as well. Okay, so what do I do on a daily basis? Very similar to what Jason talked about and what he does there in Mississippi. I do the Texas Well Owner Network. We do water quality screening, and we do educational programs to go with those screenings. We have 2 types of programs that we do deliver here in Texas. We have a well-educated or a 4-hour program that deals with the water screening or water sample screening. We test for E. coli. We test for coliform bacteria, similar to what Jason was talking about. We look at nitrate levels. We look at the pH of the water. We also look at the total dissolved solids, TDS, of the samples. We vary in range across Texas. Our classes have the water screening. We talk about aquifers, well basics in those classes. We also talk about the OSSF or the septic systems. Jason mentioned briefly on that as well. So anywhere we go, typically if you're on a private well, you have a septic system or your own on-site wastewater treatment. So we have to kind of go into those options and talk about that, because those 2, the private water wells and septics, are very, very closely related. We also have a smaller, shorter 1-hour version of our class We do the water sample screening with that, and then we talk about those results with the participants that come to the class. And basically, we talk about wellhead protection whenever we are doing the small or the shorter 1 hour class. So both of them are very similar. A lot of the topics are the same. We have got it set up now so that whenever you come to our 4 hour or our 1 hour meeting, we actually give you the results on the day of the meeting. Typically, we come in a day prior to the educational event and do the water sampling so that we have those samples to folks whenever they show up for the educational presentation. Okay, Texas Well Water Network programs. The program was established in 2011. We've had about 10,000 plus participants in our workshops over the last 12 years, over 200 events. We've covered 180 of the 254 counties within the state. And again, our water sampling, we do look at E. coli and coliform bacteria. We look at nitrates, look at the TDS, total dissolved solids. And in other locations, as driven by the aquifers and the water, we do look at arsenic in several locations. Texas, we have 5 or 6 hot spots for arsenic. One is down along the Rio Grande towards the southern coast of Texas. We've got one in far west towards El Paso. Then we've got an area in Midland, Odessa, kind of a central west that has arsenic issues. So any of those places where we go that arsenic has been detected, we do the screening for arsenic as well. The one word that may get you on our stuff here, it says water sample screening. We are screening samples. We are not a certified lab. We do not have certified equipment that we go. Ours is a mobile lab. We go from county to county, from location to location across the state. So we are screening for samples. If we do see something that the E. coli, the bacteria, is anything that we see that is off the charts that we feel is a good positive test, we're going to request that the well owner take their sample and go to a certified lab to verify our test and to make the proper treatments for their water samples. Okay. They did ask me to talk about groundwater depletion over time. So first we'll go into a couple of definitions of what that is. It's the definition of depletion or groundwater depletion is a long-term water level decline caused by sustained pumping of groundwater. It occurs when the water demand through the pumping exceeds the water supply through recharge. Right now in Texas, this is a very common occurrence. We've been in a drought this summer, so our pumping is definitely exceeding the supply recharge because we have had no substantial rain here in the College Station area for about 90 days now. So typically that's puts our private wells and our public supply wells in danger of water usage going out and restrictions being implemented. Okay, groundwater depletion, where aquifers can be compared to a bank account. Groundwater is the money that's within that account. The water can be recharged or deposited by infiltration from precipitation, from surface water to irrigation. It can be kept in storage, saved in that aquifer, and discharged naturally through streams, springs, and transpired through the plants that are growing out in our fields. In naturally occurring systems, recharge and discharge are nearly at equilibrium. So the amount of water being recharged coming into the system is what we are discharging and our actual usage. The water volume remains relatively constant, but in years like we have now, where there is a drought situation, the recharge is way lower than what our usage is, because we have more and more folks coming into the state of Texas. Our population is expected to double in the next 25 years. So big state, lots of people, lots of usage going on at this time. There will be fluctuation over time, but once the pumping begins, the system is disrupted. In most cases, aquifer will decline over time. Our high plains of Texas, where there is lots of production and row cropping going on, their aquifers are dropping rather quickly, and they're in a type of aquifer that does not set itself up for a lot of recharge. So the depletion that's going on in far west Texas, up in the Panhandle, South Plains, is not one that's going to fix itself over time. It is one that is getting more and more critical. So the farmers in that area are very good stewards of conservation and have learned how to minimize the amount of water that they're using to get the most maximum profits on their investment and to get those crops out of the field. Okay, groundwater depletion is a kind of a result of climate change from what we're studying and seeing today. The climate change is contributing to the groundwater depletion with changes in precipitation and the temperature patterns. I don't know if you know what's going on in College Station, but we had 69 days over 100 degrees this past summer, which the news said this week that we have set a record for the most consecutive and most days over 100. I think we had 45 days when the temperature reached at least 105 degrees. So temperature change is definitely playing a part in the groundwater depletion. The drought is also playing that part. As you can see, Texas on the map is the whole state, except for just a few counties, is in some sort of moderate drought. The big red section right there in the middle is a more dry spot that has not had a lot of rainfall probably in the last 90 to 120 days. Seasonal temperature outlook, we're kind of like the Arizonas and New Mexico. We have got above our seasonal temperature outlook, and it's not looking like we're going to break that. We did see one little day when we got into the low to mid 90s, but typically we're right there at the 95 to 99 over the last, couple of weeks. Okay, groundwater depletion is the volume of water that is stored and decreasing in many parts of the United States. Again, this is not just a Texas problem. This is a statewide or a nationwide program or nationwide problem that can happen. You see that New Mexico, Arizona, California, they're all in various states of groundwater depletion. So it's, like I say, not localized to Texas, not localized to the Southeast. It is going across the Western United States, and it can really affect many, many of us. Okay, causes, effects, and solutions for our groundwater depletion. Aquifers hold vast amounts of water, which can provide us billions of gallons of water to use per day. Whenever we start talking about lots of water, we start talking about acre feet of water. Acre foot of water is 1 acre of water placed over 1 acre of land. So I'm a visual person like Jason. So when I start talking about acre feet, everybody picture a football field in your mind. Put 1 foot of water on top of a football field, and that is what an acre foot of water, about 326,000 gallons of water. So, put billions into that 325,000, 326,000. So we use a lot of water. Groundwater contributes an estimated 40% of the fresh water that is used around the world on an annual basis. Agriculture needs require a large quantity of groundwater to produce crops, livestock, and to maintain human consumption needs. Okay, so, one of the large users of water is our farmers, our producers, but one of the best conservationists that we know are our farmers and our ranchers, because they have learned to take as few drops as they can to maintain those crops. You can see on the chart here, at one point in the 60s, we were using vast amounts of water. As we get into the 2010s and 2020s, we're still growing the same amount of crop, if not more, but we're using significantly less inches of water, acre feet of water. So farmers, ranchers have learned to take those drops and sustain what they're doing and utilize them to the most maximum benefit. Okay. Most commonly occurs because of a frequent pumping of water from the ground. Water is pumped more quickly than it can renew itself, leading to shortages in the groundwater supply. A growing population results in human consumption taking the water from underground more rapidly than it can be replaced. Again, Texas population expected to double. We're still going to have the same amount of groundwater, but we are looking at taking it out a lot faster because the population density is increasing across our state. As we pump the groundwater from our aquifers, the free-flowing water does not have a time to replenish itself before we're trying to take out more. So, the rainfall that we do get, we are infiltrating into our aquifers, but it's just not coming at a substantial enough rate and time to replenish the aquifer for the amount of drops that we are pulling out at this point. Okay, depletion can occur naturally due to climate changes that alter the world's natural processes. we're having shifts from consistent rainfall events to extremes. You can see that across the United States this year. Texas is in a drought. The Northeast part of the states, they were in flooding a couple of months ago. So it's either feast or famine. We go from one extreme to the other. Droughts, floods, it's always happening. Hurricanes, really, they're going to bring some flooding in, but that's not the kind of rainfall events. I thought the flooding that we're talking about with these, with our groundwater depletion, that's just a weather phenomena that comes across, and hopefully we never wish hurricanes on anybody, but Texas could sure use like a small hurricane to come in and hit the Gulf Coast again. Texas is very parched, and we would love to see a little rain. We never wish those category 5s on anybody, but category 1 or 2 that's going to bring a tropical depression and give us some rainfall, we always would love to see those. The shifts in temperature increase the evaporation rates and remove soil moisture more rapidly. Any of our surface bodies of water that we see, with the temperature of 105, the evapotranspiration goes really high. So the water from lakes, streams, the backyard swimming pool, you can notice that the water is evaporating out of your pool really quickly in the summer months here, so that you're having to add more water to keep that level up, to keep the pump from burning out. The lake levels we've got, there's a couple of lakes in Texas that between here and San Antonio that have dropped to significant amounts, that there's only like 5 to 10% of the water that's left within that lake. So the recreational uses, any livestock uses, any kind of wildlife uses are non-existent at this point, because you've got less than 10% of the water body with the water there. So very significant difference in use of water. Okay, some of the effects of groundwater depletion. More groundwater that is extracted from shallow aquifers will force us to drill deeper boreholes to maintain our current use. As we drill deeper and use up these supplies, they will also deplete over time, because we do have that population. We will find less usable potable supplies. The typical reason why we drill, I saw Jason's thing a while ago. It said that the typical well is around 300 feet in Mississippi. In Texas, we're probably 400 to 500 feet is our typical well. People stop at that first potable water because of the cost that it takes to drill a well. In Texas right now, it costs about $25 to $26 a foot to have a well drilled. So whenever you hit potable water at 400 feet, it may not be the best. It may not be really great, but at that price, you're going to stop at the 400 or 500 feet when you hit good water. The next usable water typically is going to be down there 900 to 1,000 feet. So people just can't afford to drill down into the aquifers to get to those supplies. But as we do deplete the aquifers that are closer to the surface, we are going to be dependent on those next aquifers. And the problem is, water quality is always not, or may not be as good as what we've got now, or it may be better. You don't know until we tap into that water. Typically speaking, the water that we have found, it's pretty decent, but it does come with some hydrogen sulfide. That rotten egg smell typically comes into that deeper water. So it's not something that we like to smell, but it is good enough water. We just have to aerate those waters whenever we bring them up to the surface. Okay, we will have to develop resources to find other ways to drill further into the ground and find those next supplies. Consequently, this will cause the resources to be developed and new technology to be added. So in my mind, I see that as new technology is added, we're going deeper. That price is going to go up as we get to this because of these consequences. So we're looking at probably $30 to $40 a foot to drill a well down to that 900,000 or over 1,000 feet deep. So private wells could be at danger of people won't be able to drill those, so they're going to have to get onto public supplies. So it's going to be entertaining as we move forward in time. Groundwater shortages will cause depletions of surface water as well. This means that the water from springs and other naturally occurring seepages will no longer be able to sustain many lakes, rivers, and streams. The underground hydraulic pressure is going down, so therefore that water that's in the aquifers will not be able to force itself to the surface So it's not going to be as much water being utilized because it's not coming to that surface anymore. Less water will enter the surface water bodies. Evaporation will cause them to become shallower, as again, several lakes across the state. And this causes these water bodies to be unusable. Along our Gulf Coast, saltwater intrusion is a possible contaminant. As the fresh water is depleted, saltwater replaces it because the hydraulic pressure is going down. So that means that salt water from the Gulf of Mexico, as we're pumping water from the city of Houston, under the city of Houston, salt water does intrude into those aquifers, causing this water to be unpotable, causing us to have to either use desalination to make that water useful or drill deeper into other aquifers to find more potable water. Okay, groundwater depletion may limit biodiversity and cause the appearance of sinkholes as the aquifers are emptied and voids are formed underground. Okay, an aquifer in the hill country of Texas is in a limestone formation, so water does not readily enter some of these caverns. As that happens, the dissolution of the limestone may cause weakness, and we may have sinkholes like you see on the picture coming in. So the karst limestone aquifer present, drilling these wells, we're taking the water out and there's nothing going back into it. So it may cause these voids to open up all the way to the surface, therefore causing sinkholes, resulting in possibly losing livestock, loss of life as these things occur out in the middle of pastures and even close to cities where the water was at one point. Okay, easiest, most direct solution for our groundwater depletion is water conservation. Do your part, and you don't have to have the greenest lawn in the neighborhood. You do not have to keep that yard. The more you water, the more you mow. Me personally, I'm not a big fan of mowing yards, so I do enough watering in my lawn to keep it alive, but I do not have to have the greenest, most lush lawn in the neighborhood. Okay, reduce the use of pollutants to keep the water supply quality as high as possible. We as humans are probably the biggest culprit of the pollutants, and we can, one drop of oil can pollute thousands and thousands of gallons of water. So we want to make sure that we are doing things to sustain our aquifers, that we're being smart. One thing I know Jason said is thinking about a water well, it is a closed loop system. So from the time water enters the well column at the pump till the time you open the faucet in your house, there should not be a chance for those contaminants to get into your water that you're going to consume. But as we contaminate shallower aquifers, we are causing ourselves to have pollutants in those waters and not be able to utilize them. Okay, we're going to have to find alternate sources of water, possibly desalination as supplies begin to diminish. Again, not a cheap thing to do. Desal is a great option, but as for most of the United States, we're not set up to do that. One fun fact that you may not know, one of the biggest desalination plants in the world is in El Paso. So not close to any salt water body, but the aquifers there are not good. So they have to desalinate their water supplies to be able to use that for their drinking water. And just a couple of things that I talk about on my typical well owner programs, that if you've got people in your area, one thing we do want them to know is to have a well log. It's going to give us well owner location information. It's going to tell us who drilled the construction of that well. It's going to give us any kind of well testing, and it's going to give us geologic information. So you see on this well log, the top, it says the city of Rock Springs is the owner of this. It tells us that it's a 17-inch hole, which is a public supply well, not a private well. Most of our private wells, like Jason was saying, are 4 to 5 inches PVC pipe. This well is 631 feet deep. That the water level sets at 420. So we've got about 200 feet of water in this column, which is a great thing to know. The pump is set at 504. This well would pump 520 gallons per minute with 0 drawdown. Phenomenal well. Typical well in close to Rock Springs is about 350 feet deep, produces less than 10 gallons per minute. So phenomenal well system here that they've got access to. In Texas, groundwater, we have 9 major, 22 minor aquifers. They estimate that there's 3 to 4 billion acre feet of water underneath the state of Texas. If you look at Texas, we think of it as a pretty wet state on the eastern side of the state, and it gets drier and drier as you go west. So El Paso Desert, East Texas, we have pine trees, creeks, lakes, streams, all kinds of surface body of water, and there is a lot of groundwater underneath the eastern portion of Texas. On this map, if you notice the blue aquifer there on the Panhandle and South Plains of Texas, that is the Ogallala aquifer that goes up through the Midwest. Again, this aquifer is in dire straits. It is one of those that is depleting regularly, and we have lots of production agriculture going up there, lots of livestock. So the loss of this water is going to be devastating as we move forward with our population growth. Okay, is this a problem with a well? As long as your pump stays good, everything is working, it's not a problem. The problem with having roots within your well system are when the pump goes out, how do you get this pump out of the bottom of this well? You give it a little tug when the pump installer, the well driller comes out to remove the pump, to put a new one in. He gives this thing a little pull, breaks the pump off, it's at the bottom of the hole. So won't be able to get that thing out most likely unless it's just this little mass. So not a problem until it is a problem. Okay, when drilling a well, make sure that the pump is installed to a depth below the standing water level, but not to the bottom of your borehole. You want to be able to lower the pump as needed and maintain your water supply. So as groundwater depletion is occurring, we want to be able to grow our well. And by that, I mean, we want to be able to drop that well down into a deeper point of the well. You saw in the city of Rock Springs, the well log that I showed you a while ago, said the well level was 650 feet. The pump was at 500 feet. So we have 150 feet that we could drop that. If the groundwater depletes over 150 feet, we still have another 100 feet or so that we could drop that pump and still be able to sustain that water supply for the city. A private well is the same thing. You want to be able to drop your well as time goes by. Okay, 5th grade science right here, guys. Hydrologic cycle, very important whenever you're dealing with wells. To get the water from the ground or into the ground, we have infiltration percolation. When it means it hits the ground, it infiltrates through the soil and eventually percolates down into our aquifer. Precipitation is what recharges our wells. Okay, think about it. Precipitation and recharge is not going to occur locally in most instances. Most of the time that's going to occur in Texas for sure. It's going to be north and west of you. Whenever they get rainfall, that's where the water recharges. That's where it percolates into the ground and actually fills the aquifer to flow where you're living if you're in the southern part of the state. So what I tell my folks when I do programs is pray for rain locally. That keeps your trees alive. That keeps your livestock alive. That keeps things nice where you're at. But always pray for rain for those folks that are north of you, because that is the rain that recharges your aquifer. So just always keep that in mind. I think that's probably very common across the southern United States. People to the north of you, whenever they get those rainfall events, that helps you out locally. Okay, aquifer recharge is the key component of the hydrologic cycle. Recharge occurs locally in some instances in these karst type limestone aquifers. If you've got cracks and crevices in the ground, you do get some recharge right away, but typically speaking, in our sand or our clay type aquifers, recharge is going to happen in an area some distance away from us. It's going to take some time, and as the water percolates through the aquifer, through the soils, it does help with that recharge event. Okay, what you do in your property can affect your neighbors. So if you see the picture there on the left, your original well is pretty shallow. So as normal use of water, you're going to see that if we normally use that, we're going to start drawing air because our aquifer has depleted over time. So this is the picture that I wanted to show you that shows how you want to be able to deepen that well, how you want to be able to move that pump into a lower formation into the aquifer so that you do keep your groundwater use where you can use it. Okay. Septic tanks are a very common thing, again, whenever you have a private well. So we want to make sure that septic tanks are properly maintained. We want to make sure that those drain fields are properly maintained so that they do not contaminate our wells. If we have a septic tank that's cracked, that's the leach lines are not working properly, we can easily contaminate our water supply. I mean, this shows the pictures there. If that septic is cracked and the sewage is going down through the bottom of it, it does not take long for it to flush into our aquifer and possibly contaminate what's going on with our well. Okay. This is just a graphic of Texas. If you look at Louisiana, New Mexico, Oklahoma, see how they kind of got a green or a very light colored tinge to them. Okay, the reason Texas looks orange and purple is we go to these little dots. Every one of the dots on this map of the colors is a private well within the state of Texas. Okay, this map is with our Texas Water Development Board has this interactive map. So I typed into their search engine, College Station, Texas, and these are the wells that are close to College Station. Orange ones and purple ones are things that we've got water information on. So if we click on any specific well, it's going to be able to bring up this information box. We click on the hyperlink there, and it's going to actually take us to a copy of the well log, like I showed you a while ago. So this well is out in probably 10 miles to the west of College Station in Burleson County, down in the Brazos Bottom, where another big group of farmers and irrigators are working. I think it's really close to the Texas A&M farm where we're doing agriculture research. So if we looked at this well, it's going to tell us it's a 65-foot well, which is not very deep. So it is very close to the Brazos River using alluvial water. So we have these well logs, we have this information. So well owners in Texas, if they don't have copies of that well log and they don't know what's going on with their well, this is an easy way to find that information. And why do you need to know any information about your well? Why do you need to know the depth? Why do you need to know where the pump is set? Okay, so my story with this is you're going to have problems with your well at some point. Pumps are man-made things. They don't last forever. And if you don't know how deep your well is and somebody comes out to fix it, you may get taken advantage of because not everybody that works on wells, not everybody works on cars, not everybody that does service labor for you is totally honest. If your well is 300 feet deep, we know that an average piece of PVC pipe is about 20 feet. So in a typical 300-foot well, you should be able to put 15 joints of pipe down to get to the water in your well. So if a guy comes out to work on your well, tells you that the stem that goes to hold your pump in there is all bad, we've got to replace everything, he's going to make you a heck of a deal on 25 joints of pipe to be able to put your pump down into the bottom of your hole and be able to take the water from the well and put it into the house. Okay, how do you put 500 feet of pipe in a 300-foot hole? But if you don't know how deep your well is, you don't know any difference. You pay for it. You're happy you've got water back to your house. So you just happily do that. So the more information that you know about your private well, it's good to know how much water that the well would produce whenever it was drilled brand new. Now realize over time, if I drill a well today and it will produce 20 gallons per minute, over time and more neighbors coming in there, water does degrade, as we talked about. So you may not be able to get the same amount of water out of your well in 5 years and 10 years. But if you have that well log, you do know what the well would produce whenever it was a new well. So it does give you an indication of what it should be or where it should be close. If it's not doing that, we need to figure out if the groundwater has depleted. If you're in a limestone or karst type aquifer, a lot of times sediment builds up on your screens in the bottom of your well, not allowing as much water to enter the well column. So that's why some of the your production may go down. When we talk about water wells, again, in Texas, we are talking gallons per minute that come out of your well. If you have less than 17.5 gallons per minute, you are considered a domestic or livestock type well. And groundwater districts, if you produce over 17 gallons a minute, you're talking high volume wells. You have to have operating permits to be able to produce that kind of water. So lots of different things go on across our rather large state. Okay, correcting low yielding wells, we can redevelopment. Again, that's something that is possible. Hopefully we can lower our pump, we can deepen that well just a little bit and be able to maximize the usage of the water. So a couple of different things that can happen there. In the Western Hill Country, if our screens are plugged, one thing that they can do is really they take the pump out of the well, they pour a uric acid concentration down into the well, they scrub the inside of the well casing and put the pump back in there, flush that well out, and hopefully it knocks some of the limestone particles off of your screens and allows more water to enter. So that's one way we can correct part of our lower yielding wells after a matter of time. And I think with that, Reem, that's about 35 minutes. I think I will entertain questions if anybody has them.
All right, thank you, Joel. Again, folks, feel free to use the chat box or the Q&A box to drop your questions for Joel. And we'll take a couple of questions here before we go on to our break.
Okay, so I see the question.
Yep, go ahead.
Are you aware of local health departments or other local agencies that have begun water emergency planning and response for groundwater depletion? Nothing that I can think of right off the top of my head. Again, there's groundwater districts across the state. There's health departments that are looking at these issues. I'm sure there is some emergency planning in some of the locations that are really have this dynamic problem, but I'm not aware of a whole lot of planning that's going on right now, except for in the high plains, South Plains. The districts are curtailing the groundwater usage for the irrigators, for the farmers, to make sure that they are only using what they absolutely need. So there are plans in place to keep the water usage at a minimum, but still maintain the crops that we need to sustain food and fiber for all of us that are going for us to be able to use. I mean, every one of us here probably has some kind of cotton clothes on today. We're probably going to have drink some kind of milk or use some kind of dairy product. There's lots of dairies in that area. There's lots of cotton farms, so lots of corn farms, so many things that maintain and sustain what we do. So hopefully, I know that they are conserving and doing what they can to protect that resource in that area.
Great, thank you, Joel. We have two more questions in the chat box, one from Judy and one from Catherine. If you want to take a look.
All right. Let's see, Judy, what is your thought about injecting water into the well, say from a public system? Okay, so there is a lot of aquifer storage and recovery projects going on, which is kind of what I think you may be asking. And it works in some areas, like in a karst type aquifer out in that hill country where I was from. It doesn't work very well because once you pump that water in there, it will displace itself. I know south of San Antonio, or for the San Antonio area, they are using aquifer storage and recovery projects. They can actually pump water into a sand aquifer there south of San Antonio, know exactly what kind of bowl it's filling, and be able to pull that water out in times of drought like we've got now and utilize that water. So aquifer storage and recovery is a viable option in many locations, but depending, it's kind of an aquifer driven. If you're in a limestone karst aquifer, it doesn't work so well, but if you're in some of the sandy type aquifers, it's a real viable option. So it can work in certain localities. And does Texas have any water restrictions in place to force people to use less water? And again, it's going to be a county by county, a city by city driven policy. Most of the districts that we've got do have drought mitigation plans in place. Our larger cities have those drought contingency plans in place as well. So at this point, people are being asked to curtail that lawn watering to 1 day a week, 2 days a week, just to make sure that we are lowering the numbers until we do get relief from the drought situation. So yes, restrictions are in place. Every county, like I say, I think there is a drought contingency plan involved in planning. We do have what's called desired future conditions, where we want our aquifers to be in 25 to 50 years. And every one of those plans is using conservation efforts and to maintain our supplies and to get to that desired future 25 to 50 years down the pike. What do you think has been the biggest factor influencing farmers' water usage to decline despite higher productions? I think our farmers are probably the best conservationists we have out. They know exactly when a crop needs water. They've got the technology now to say when it's dry, when they need to water. They utilize as much of the soil profile water as they can before they have to irrigate again. They put as little water on to maintain, sustain, and build that crop. So in my working with cotton producers and peanut producers, they are really smart people. They keep up with the latest and greatest technology and science to be able to maintain those crops and build them as good as they can. So really good people to conserve and move forward with. And I think the UV system may be one more for Jason.
Right. Thank you, Joel. At this point, let's take a break. And like I said earlier, if there are some additional questions, we will try to catch those during the discussion session. At this point, let's break for about 10 minutes. So let's try to be back at our desks by 2:15, roughly Eastern time, if you are on Eastern time. So hope that helps, and I'll see you folks soon. Thank you. All right. I want to give folks maybe another minute, just so everyone gets back from their break. All right. Okay, let's get back to our workshop. At this point, let's move on to the third session in this workshop. And Sam, I'll turn it over to you. You should be able to share your screen.
Right. Yeah, are you guys able to see my screen?
Yes, I can see your screen, but I see it in the PowerPoint mode, not in the, there you go. Perfect.
All right. Good afternoon, everyone. I'm very happy to, present about some of our prior work and give you a broad overview about the impact of climate change and associated saltwater intrusion on private wells with a focus on how salinity may impact water quality and health. Before going over the presentation, I want to share that I'm currently serving as director of the Center of Climate Change and Health at Morgan State in Baltimore, Maryland. Before moving to Maryland, I was in Louisiana and New Orleans. So I worked with, a lot of private well owners in the state, and also worked with colleagues at Louisiana State University, trying to understand the impact of saltwater intrusion, mainly on groundwater quality and groundwater microbiome. So here's my outline. So today I'll be talking about, what is saltwater intrusion, talk about some examples of saltwater intrusion in the US, and what are some best practices to prevent saltwater intrusion, and what to do if, your private well water is impacted by saltwater intrusion, and some questions at the end. So right here, saltwater intrusion, it's the process, by which saltwater infiltrates a coastal aquifer, and it leads to contamination of fresh groundwater. So this picture right here, figure illustrates, the process of saltwater intrusion into an aquifer system and how it can occur. So the first on the top right, it's when under natural condition where there are few wells along the coastline, you can see the water table. It's going to remain high, and the resulting pressure and prevent saltwater from intruding. So this boundary between the freshwater and saltwater right here, it's referred as the freshwater saltwater interface. And this is the kind of transition zone when you have freshwater and saltwater mixing. So under natural condition, the seaward movement of freshwater kind of prevents the saltwater from encroaching the coastal aquifers. But when you have, rapid pumping or overextensive pumping of these, water along these coastal aquifers, it can lower the water table, as you can see here. And lowering the water table, it reduces the water pressure in the aquifer, and it allows the nearby salt water to move into the aquifer and contaminate well water with salt. So if too much fresh water is pumped from the aquifer system, then salt water can migrate towards, and that's the process known as saltwater intrusion. So as I said before, the saltwater intrusion can occur due to either natural or even human activities. So this picture also right here shows, how saltwater intrusion can occur, as you can see here, under natural conditions, and when you have, over pumping of groundwater, fresh groundwater. And then if you look at, how it can impact, or the climate change can impact, you can see here the natural process versus human activities. So under natural state, the fresh water, it flows of the land and into the water table and tributaries. But there are, periods where in the tides and storms, they bring brackish water. In this case, from like Maryland estuaries, tidal tributaries, and the ocean onto the land, further upstream and further inland underground. So I will give you some examples, how it's kind of implicating some of the agriculture sector in the state of Maryland, mainly in the eastern shore. And in terms of sea level rise, you can see this, the down figure where climate change, it's increasing the intensity of storms and flooding. As you can see, the sea level rise will bring, more salt water or brackish water onto the land further upstream. And that can, contaminate the ground. And as you can see, with sea level rises, the low-lying land becomes more difficult to drain due to higher groundwater, resulting in less removal of salt from the land over time. So this right here phenomenon shows, how the relation between freshwater and groundwater or the saline salt water can impact, the water quality. So in the state of Maryland, you can see in the eastern shore, we have, a lot of challenges in terms of saltwater intrusion. So over the years, we have seen, increase in salinity in groundwater, mainly in right here around Ocean City and Salisbury and Eastern Shore, where farmers, they are struggling with how to cope with saltwater intrusion that, kind of decrease the crop yield in this area right here. And you can also see the water systems that are impacted by salt, which can be in the larger cities like Ocean City, mainly tourist city, and also some private wells right around the eastern shore. But also in larger cities like Annapolis, Kent Island, the water systems been impacted by salinity. So a lot of these wells, are impacted. And the farmers, when they are using this, to grow soybean or corn in this area, are struggling to use other water sources or to implement, the treatment methods to use irrigation water. But that's not the only place. If you look all over the U.S., there are many examples. The saltwater intrusion occurred in different coastal areas in the U.S. And I think one of the area that's, historically very well documented is in Southwest Florida, in Miami. So you can see this figure right here that shows you, how saltwater intrusion extent in different periods from 1904, 1946, 1977, and 1995. So if you look at this, the different time period, you can see that in 1904, you can see the extent of the saltwater intrusion at the base of Biscayne Aquifer. This was prior to the construction of the regional drainage network and water supply wells, very high water levels in the Everglades and the aquifer. And in 1946, you can see there was, some canals establishment, and along with 1946, you can see this canal right here, 1977. So the uncontrolled drainage in the southeast Florida was halted by, some areas reversed the inland migration of salt water. And in 1995, you can see this saltwater intrusion extent compared to 1904. So the canals are also used to transfer fresh water from inland water conservation areas to coastal reaches where the water is artificially recharged to the aquifer to raise coastal groundwater levels. And then there are different factors, that kind of lead this saltwater intrusion through different various ways. So you can look at the sources of saltwater, including freshwater aquifers in Florida, for example, like encroachment from ocean, also infiltration from tidal marshes, both basins, estuaries and bays, also leakage from unprotected canals, and upward leakage from deeper aquifers, and also movement of residual salt water from previous sea level stands. So there are different ways these aquifers can be impacted with salt water. And in the U.S., there are several other examples, like, in all over the coastal areas, like in New Jersey, Long Island, New York, in Georgia, Florida. So you can see here, this is a prime example in the Old Breeze Aquifer in New Jersey, where they were monitoring the chloride concentration in well water. As you can see, since 1950s, a composite graph of chloride concentration in water samples from wells screened at about the same depth in the Union Beach Borough well field. So you can see over the years, the chloride concentration in water samples increased significantly above background levels and increased steadily over after that time. So you can see here almost 1,000 milligram per liter compared to less than 10 in 1950s. So as pumping in the area caused water levels to decline below sea level, the saline groundwater moved landward and caused the increase in chloride and dissolved solids. So as a result, with this, a lot of these wells, they were abandoned in the early 1990s and replaced by other wells further inland. You can also look at another example here in southern part of New Jersey, like Cape May County. This figure right here, it shows you the chloride concentration in milligrams per liter in different time period, 1940s, 1950s, 1970s, 1990s. So Cape May County, New Jersey, it's is on a peninsula that is surrounded by the Atlantic Ocean and the Delaware Bay. So it has a multi-layer sequence of unconsolidated, predominantly sand and gravel aquifers, and over the time you can see the concentration of chloride being less than 50 to 100, and over in 1990s, greater than 1,000 milligram per liter. So over the years, you can see there's saltwater intrusion in this aquifer in different coastal areas in the U.S., New Jersey, Florida, Georgia, North Carolina. You also can see some of these in the Gulf state, as previous Joel mentioned, in Texas, Louisiana, and also Mississippi in the Gulf states. So when I was in Louisiana, we had this big problem of saltwater intrusion, mainly in the southwest Louisiana and also southeast Louisiana. So we received a grant to look at how saltwater intrusion impact, groundwater quality, private wells, and also how it impact the groundwater microbiome if the salinity, changes the microbiome of the groundwater. So we collected, more than 100 private well water samples across southern Louisiana, like in New Orleans areas. As you can see in this map, along Lake Pontchartrain, we had several private well owners agreeing to participate in this study. So over a year, we collected over 100 well water samples, and then we quantified, E. coli, which is traditional indicator of water quality, but also we wanted to know how salinity and other, parameters can impact proliferation of other emerging pathogens like Legionella, Mycobacterium, Naegleria fowleri, which is a brain-eating amoeba. We were particularly interested in this Naegleria fowleri because there was a case in southern Louisiana in New Orleans when, we had several positive detection in public water systems. So we wanted to know how, its prevalence in the private well water system. So it's published in the Journal of Water and Health, but I will just go briefly over some of the results. So when we did some correlation analysis looking at how water temperature and salinity impact, the proliferation of this pathogens, we found that the water salinity was, positively correlated with mycobacteria right here with 0.23 R value and significant p-value less than 0.05. But it was not the same case for E. coli and Naegleria fowleri, which was in the negative correlation, as you can see, minus 0.13 and minus 0.32. So there are very limited studies, looking at how salinity changes can impact the proliferation or growth of these harmful opportunistic pathogens in private wells. So mycobacteria is, increasing in numbers in tap water, and especially it's very concerning in New Orleans and southern Louisiana because we have very high number of cystic fibrosis patients. And if they are relying on these private wells and, if salinity may increase the concentration of these harmful bacteria, it might, have adverse health effects for these well owners. We also looked at, E. coli and water temperature, which we found a positive correlation, 0.54 and a p-value less than 0.01. So after this study, we also looked at, how flooding impacts, private well water during hurricane season, like Hurricane Ida. And I will also show you how some of these changes in groundwater quality can impact groundwater microbiome as well. So we, we had these water samples, we extracted nucleic acid, and we did next generation sequencing to also look at the microbial community. If you have higher concentration of salinity, does it change the groundwater microbiome? We did not have significant, changes in this study because we only had, 100 like raw private well water samples, and we're trying to continue this. But overall, you can see the abundance of dominant phyla in private well water, starting with proteobacteria, which we found, the highest 71.1%. And within that, the gamma proteobacteria, delta proteobacteria, and beta proteobacteria and alpha proteobacteria. But we also found, some of this other interesting, the phyla, for example, cyanobacteria, 2.2%, bacteroids, 2.0%, and actinobacteria, 4.2%. So, which is, like opportunistic pathogens. So, as I said before, the studies looking at how saltwater intrusion or changes in salinity concentration can impact groundwater microbiome and also the other water characteristics. Very limited studies done in private well systems. So we were trying to understand this during the hurricane season as well as during dry seasons. So besides my study looking at how saltwater intrusion can impact, groundwater microbiome, I want to also talk about, how we can prevent the best practices for prevention of saltwater intrusion. So first, we need to understand, what are some of the risk factors for saltwater intrusion. So if the well owner, as a well proximity to coastal areas like 500 meters, is at higher risk of, of having saltwater intrusion. Also, if it's a deeper well, like which is greater than 200 feet well depth, and also it depends on the pumping rate and well density, and also depending on the areas at higher risk, like low-lying regions and peninsulas. So the best practices, to prevent is to know what's going on in your groundwater. So we have to test, well water for signs, for example, electrical conductivity, the total dissolved solids, and the chloride concentration, if it's greater than 150 milligram per liter. So if you can see here in this picture, with excessive pumping of, the freshwater, groundwater, you can see that in the case of sea level rise, this interface between saltwater and freshwater increases, lowers the water table, and you have, the saltwater intrusion. But what areas are at higher risk? So as I said before, close to the coast, but also, depending on, the low to moderate slope in terms of understanding the saltwater intrusion, also high density of wells, and also high rates of pumping. So how we can avoid, some of that if your well is impacted by saltwater intrusion. So first of all, you need to, get water tested using a certified lab. So if your salinity levels in your well are too high and increasing at a rate that will impact water quality, you have several options. You can also, treat using reverse osmosis, which is not very ideal for these homeowners because it's a little bit expensive. So you have reducing or adjusting your pumping rate. So mainly reducing your water use. So water conservation, filling in part of your well or raising your pump and obtaining a new water source. So mainly shallow drill well or dug well. And for homeowners, you have to know the risks. So before, trying to drill the new well, you need to know what are some areas that are risk of saltwater intrusion, and also educate property owners, site managers, or water system operators that their well or locale could be affected. So overall, you need to understand some of these risk areas, and if it's impacted, you also need to consult a certified well contractor to, explore your options in terms of getting the water treated, or also, drilling the new well. So there are very limited, studies looking at how salinity or saltwater intrusion can impact, the private well owners in terms of economic costs. Most of the studies are looking at in agriculture settings where, farmers are using this well water for irrigation and yield crops. So in terms of potable water, there are very limited studies. So in the future, the more research needs to be done. So just to summarize, the saltwater intrusion is a growing problem, and in the next few years with climate change and sea level rise, you will probably see more private wells getting contaminated with, higher salinity concentration. So the best thing is to educate and let the homeowners know, what are some of the risks of saltwater intrusion, and with climate change and sea level rise, what they can to protect, some of their like the resources. So that's all I have. I left more time for questions, so I'm happy to answer any questions that you have.
Thank you, Sam. All right, if you do have any questions for Dr. Shirchan, feel free to drop them in the Q&A box or the chat box. All right, looks like we've got a question from Alexandra. She says, I saw something about ghost forests on one of the maps. How are they affected by saltwater intrusion?
Yeah, so that's the map of the eastern shore, Maryland, right here. So with saltwater intrusion, you can see some of these agriculture fields are getting replaced by, marshes, saltwater marshes taking over in some of these areas. And then you can see some of these trees that without, leaves, or so that's kind of ghost forest without any branches. And you may see, some nest for birds and stuff, but technically, they are kind of dying. So you need to learn how, saltwater intrusion can impact some areas. So farmers around here, they are using different technologies like drip irrigation, and also using like AI and machine learning to prevent some of these areas right here where they are decrease crop yields. So that's kind of the ghost forest, mainly in the eastern shore around here. And this is the area, the Chesapeake Bay, which is a national source and very rich in seafood and other resources. But you can see the salt water, the levels inwards compared to a lot of these estuaries. So a lot of these farmers are kind of having problems with how to deal with saltwater intrusion.
All right, thank you, Sam. Any other questions? And as folks are putting in more questions into the chat box or the Q&A box, I know we didn't have a chance to address some of the questions earlier for Dr. Barrett. Let's revisit those questions before moving on to the discussion session. And Jason, I know you've addressed some of the questions in the Q&A box directly. Do you want to read those out loud so we can share that and it gets stored in the recording?
Yeah, I think I'm pretty sure I only responded to one that I typed in. And let me see if I can, Q&A here. Okay. Yeah, the question asked, at the beginning, he mentioned that well drilling is not regulated. When would a homeowner require a permit to drill a well in Mississippi? So let me, I guess just for complete clarification, well drilling in Mississippi is regulated. You have to attend, certification course to have a license to be a licensed well driller. You have to keep up with CEU hours to maintain that license. And once when a well is needed to be drilled, it must be done by a licensed well driller in the state of Mississippi. So anyway, there is some regulations on well drilling, but you do not have to actually pull a permit or purchase a permit from Mississippi Department of Environmental Quality until the well casing is 6 inches or larger. Just about everything we see in Mississippi for private wells is a 4-inch well. So the well owner, the homeowner, can simply call a licensed well driller and say, we need a residential home well. And the well driller can come out, drill the well, and they're supposed to submit the drilling log back to MDEQ, which gives all, of course, the drilling log information. Part of it also is where is the well. We're finding that is probably where we're missing a lot of wells, is that well drill log is not getting submitted. Because when we have a permit pool, you're having to pull the permit. MDEQ is going to go out and validate that it's drilled properly. So you have a lot of data and data points on those permitted wells, but on non-permitted wells, we don't. So again, well drilling is regulated itself, but you're not required to pull a permit unless the well casing is 6 inches or larger.
Great, thank you. And there's been some conversation in the chat regarding UV filters. Is there some clarification you want to provide on that? I think we had a question from Mr. Khan about
on what now?
Filters for bacterial decontamination. Are those cost effective?
I didn't see it. I
can drop it in the chat again. Yeah.
You're dropping it in the chat. This is where you say, it appears you are an advocate of UV filters for bacteriological decontamination of domestic wells. Are those cost effective? Yeah, and I'm not exactly sure who posted that question. But when we think about bacteriological treatment, the mass that we see, in Mississippi and across the Southeast, people are going to be either using gas chlorine or sodium hypochlorite, like a liquid-based chlorine, to kill bacteria. But we all know with that, your volume and time, you need that detention time and contact. And when it comes to private well, mainly we don't have that. And then dealing with gas or liquid chlorine can be, it can be just an issue. To me, definitely you wouldn't want to use gas because you're not going to have the volume. It'd take you 20 years to use up a 100-pound cylinder of liquid. So of gas. So I highly wouldn't recommend that. So one of the things that we've looked at, I've just tried to think about ways if I'm a private well owner and I want to reduce any type of sediment and I also want to kill bacteria, huge advocate for any type of sediment filter that we can get, as long as you size it properly so it doesn't restrict your flow. But UV, I've met with a couple of providers, and again, I don't really advocate any one over the other, but UV just seems to be a cost-effective way that a homeowner could reduce bacteria or eliminate bacteria in their system. And I don't have any cost in front of me, but that is the one that I've seen that I think could work well.
All right, thank you. Okay, I guess at this point, if you have any questions for all three speakers, feel free to drop those in the chat. We can cover those, but if there aren't any further questions, we can go ahead and move on to our discussion section. So I'll go ahead and share my screen. All right, for the discussion, feel free to raise your hand. I can unmute you. This is truly meant to be, an exchange. We want to hear from you folks. But if for whatever reason you're not able to speak up, feel free to share in the chat box and I'll read your comments out loud. And we do have a series of questions that you can use, but please don't feel bound to the questions that we're suggesting. Feel free to discuss any topics you would like with regards to the title of this workshop. So I've got questions organized in three sort of categories, so to speak. I've got these questions that are general to all three topics that were covered within the workshop. And then I've got some topic-specific questions, whether it's for microbiological contamination, groundwater depletion, or saltwater intrusion. And the last category is sort of best practices and building resilience. So we really want to hear from you. I will leave these questions. We'll begin with general. If something, one of these questions is something that you would like to respond to, like I said, raise your hand and I can go ahead and unmute you. And take a moment to sort of, go through the questions, digest them.
Okay, so it looks like we do have one question. It's we're seeing wet springs and dry summers, boom or bust, that are causing well pressures to lessen late in the year due to the drought. Do you see any long-term issues with this type of new cycle starting? And in my opinion, we don't know what we're going to get until we get into to figure this cycle out. I mean, as long as we've got the opportunities for those aquifers to recharge, replenish, then I think we're going to be in a good position, good things moving forward. If we get this prolonged drought that lasts for years and years, then I think it could cause detrimental effects. I mean, it's yet to be determined what the effects are going to be. I mean, wherever you're at there, Greg, it sounds very similar to what we're seeing in Texas. We're boom or bust as well. We were wetter in the spring, very dry during the summer. Hopefully we're getting to our extremely wetter time of year as we move into the fall. So I hope that the cycle that we've got for feast or famine is not what we're going to get. I would love to see what they classify a normal year. I don't remember what that is. It's been so long since we've had one, because we do seem to do what you were saying, drought or extremely wet. So it's just, I hope we don't have to relegate ourselves to this type of weather patterns. I hope it's just outliers in the weather patterns, and we do get to back to some sense of normalcy as we move forward. But
And hey, if I can jump in there and kind of piggyback off of what Joel was saying, it is interesting because you dial it back in Mississippi, Arkansas, Louisiana, we catch the southern ends of the Mississippi River before it hits the Gulf. I think it was 2018, 19, 20. We had 3 springs in a row where the river was high, very high, and stayed very high for a long time. And we had people that were real concerned about this excessive flooding. We got water everywhere. What are we going to do? And it's so quick that we turn around and we've had 3 springs now where it hasn't flooded. The river hadn't gotten out of its banks, and it's been relatively dry. So I find it very interesting that we seem to have these kind of, because I feel like I've seen this ebb and flow. We tend to have these short memories on when we have water and when we don't have water in different parts of the country. So if anything, thinking about the question of wet springs, dry summers, I mean, part of me, I try to learn to appreciate when we have either one of them. But my biggest thing is always just encouraging people to just be conscious of their water use. I mean, Joel said it earlier, but ever since I got into this field, I don't water my grass anymore. For one, grass has been around a long time. It'll be around a lot longer than I am. So I just think that's not a wise use of water. And then especially when we start having these drier summers, is it really worth it to water the yard? And what kind of strain does that put on our water supplies, much less the groundwater aquifers themselves?
All right, thank you. And thanks, Greg, for your question. I see that you're hailing from Western Colorado. That's helpful. See that Mary's got a question, but before we address Mary's question, Purcell has his hand raised. Purcell, I'm gonna allow you to talk. So if you wanna go ahead and join the discussion, you should be able to unmute yourself and share.
Yes, here in North Carolina, we've noticed that, especially since Matthew and the one after it, that well yields here in North Carolina has not been what they were before those storms. I don't know what would be a cause of that. We are not very high above sea level, we're actually below, but we've noticed that since the hurricanes. And one more thing that we've noticed is the drought has affected a lot of our wells. We are now having to go deeper, whereas before we could hit water, and I mean good stream, quality streams, excuse me, 50 no more than 75 foot deep. So now we're having to go twice that, 100, 200 foot. Because of the drought here in the last few years. Now this year we've overwent our rainfall level, but in years before we've had to go deep.
Thank you, Purcell. All right, I guess I could read Mary's question out loud, and to all 3 of our speakers, whoever wants to respond, please do so. Mary says, the discussion of emergency weather changes to groundwater systems is important and valid. Wondering thoughts on availability and regulations for mobile water testing for these situations. It seems getting samples to a qualified lab is part of an issue. Getting mobile units certified is also problematic, though.
I mean, I think any of us could answer this, but I may jump out there, Joel, unless you got something pressing on your mind.
Oh, go ahead.
Okay. Yeah, that's a really good question, and I'm gonna kind of tackle it from a couple of angles. You heard Joel say this earlier. On all of our forms, we say private well screening, not testing, because we are not a state certified lab. And we got our lab here at Mississippi State University state certified for lead, because we also run a lead testing program here. And it is a very arduous process. Took us about a year, a lot of time, a lot of paperwork. So I'll say this, from our end, and then, we've got partners at University of Alabama, Northeastern, Virginia Tech, who we've done these sampling campaigns with. Very knowledgeable, very qualified scientists who are doing great research. So when it comes to running, bench level testing on water samples, we know how to do them. We just may not be a certified lab. So that's one thing to be aware of anytime we drop in somewhere, or people want to drop in somewhere and start testing the water. Because we could test all day long, but at some point there will be an entity of some sort that may want to validate those results. And the standards that EPA uses or the state uses will be based on their testing. Is it a certified lab at that state level, or using an EPA certified method? So that's one thing to think of. But then also, we've put teams together, like when we did IDA down here, and then as in the Harvey sampling when they tested 8,000. We've got teams that have put together quick sampling campaigns where we've tested 500 and we've tested 8,000. So it can be done. It's just a matter of mobilizing those correct, I'm gonna say, units that know how to do it and are able to do it. But it can be done. So that's not a far stretch.
And just to reiterate what Jason said, ours is a screening process. We feel very comfortable with the results that we get because we've seen enough samples come through. So if we do test positive for a bacteria, we do feel comfortable that it is. However, we think that a lot of it may not be the water that is the positive issue. It could be the sampling techniques that are the issue, because we've determined over time that we as humans do make mistakes whenever we take these samples and do bring them to well testing locations and things. One thing that we do whenever we see there has been a flooding event, we try to get with the county extension agents, we try to get with the groundwater districts, and if we're able to set up a testing campaign to just make people aware, if we can get documents out about drought or floods or hurricanes or bad weather or what to do with water issues at home, we will share those fact sheets, those documents with the county agents, with the groundwater district people. And we do make a push whenever we have flooding events or catastrophic events. We do make it a point to get out to those areas as quick as possible, just for public awareness. And I'm sure Jason does the same thing.
All right, thanks, Jason and Joel. Let's address Briley's question, and Sally will then come to you. Briley asks, in situations with droughts, what do residents plan on doing if their wells stop recharging? Are there already regulations or policies that are addressing this, or do you see actions being reactive once the situation becomes severely worse? Or what proactive steps are they taking?
Well, like I say, most of our state, when you're dealing with groundwater districts, when you're dealing with cities, there are drought management plans in place for public water supplies, for especially, maybe not so much for the private wells, but anytime that there is significant users, even the HUDs or the small municipal utility districts, all those things have a drought management contingency plan. Now, a lot of it is I'm going to say more reactive to what's going on with the situations, because it's going to affect every entity different, because every well is a little bit different. So it's hard to make a boilerplate set of rules and regulations for a county, a state, because it's just going to change from location to location. So unfortunately, we are very reactive to the severity of these droughts, but there are contingency plans that are in place that are monitored. And, unfortunately, the easiest thing to do with a drought is to curtail usage. And who wants to be the groundwater district or anybody else that is a person that says you can't use that water for whatever use you want to, but that is the nature of what goes on within this industry. So we never want to make that phone call, never want to put that article in the newspaper, but unfortunately that does happen from time to time.
Thanks, Joel. All right, Sally, I'm going to unmute you. And you might have to unmute yourself as well. Go ahead.
Good afternoon. My name is Sally Dolan, and I am with the Illinois State Water Survey. And I actually work with Steve Wilson and the private well class. So thank you, Dr. Barrett, for the shout out. So I just wanted to let everybody know a little bit more about what the program is and the other things that the Water Survey has to offer that could be some really good resources and tools for everybody on today. With the private well class, it is a free 10-lesson class that is all done self-paced. So we email a lesson a week for 10 weeks, and that allows the well owners to do it at their own pace, so they get the best benefit out of it. And then we do also with NEHA have private well class that you can take for CEUs. So if you're working for a local health department, need your CEUs, that's a great resource. Whenever you do the private well class, we have monthly webinars. And so we have different guest speakers. So, I could see in the future doing, one of the 3 speakers, they could possibly be one of our monthly guests. But then we also have well and on-site wastewater treatment system assessment tools. So whenever you're going out and you're trying to assess someone's property and you're trying to figure out if climate change may be a problem, those assessment tools might also be something very beneficial to you. If you have any questions or want anything, more information, you can reach us at info@privatewellclass.org. Thank you.
Thanks, Sally. All right. And Alexandra, I have added you. If you can unmute yourself, go ahead.
Hi, can you hear me?
Yes.
Hi, so I'm over down in Florida, and one of the things that I was thinking about during one of them was about wastewater and sometimes how those are used for things like watering grass or running a fountain or things for like public works to some degree. I'm kind of wondering, because I have heard before that they can get to the point where the water sometimes is drinkable. Could that possibly ever be a viable option for sometimes having that water set aside once it reaches that point for when there is a drought or something like that, to use that water?
Would you repeat that question one more time?
Sure. So my question is more so regarding wastewater in terms of a drought. I know that wastewater can sometimes be brought to a point where it could be drinkable, but it takes a lot more extra processing to get it there. I know in case of drought, that's a shortage of water, and I'm sure that there are in some of those places, some of the larger cities, they might have wastewater treatment plants. So maybe it's possible that some of that water could be set aside to be used in necessity, not necessarily on a daily average kind of thing.
Yeah, and I'm sorry, Alexander, I may not answer your question exactly. And Joel, you may want to jump in here as well, but the one of the big things that we see, and again, don't let me take this conversation too far, but one of the big things that I feel like we see, and you're starting to see some of these different cities they're using water multiple times. And that's, to me, one of our biggest deals here in the US is that we pump it out of the ground or out of an aquifer, we use it once, potentially come in contact with it one time, and then we discharge it or send it to a wastewater treatment system. So anytime we're able to get multiple uses out of groundwater, more particularly, I think that's great, because it's that just means that's another gallon that doesn't get pumped out of the ground just for a one-time use if we're able to use it initially multiple times. So anytime we can use water for a purpose twice, and we were just having a discussion here in Mississippi about sending some treated wastewater to a facility that may use it for cooling purposes. So you're getting multiple uses out of the water that was originally pumped for drinking water. So I think that's great. Now, when it comes to wastewater treatment and then potentially turning that right around and trying to drink it, there's a lot of treatment that would have to go on to make it drinking water safe. And then the second thing, you start thinking about storage. Where are you going to store it? For one, you give a lot of people a lot of heartburn if you start talking about pumping wastewater back into an aquifer for storage. And then also, is there anywhere, is a reservoir somewhere that you would potentially want to send this water for storage? And again, once water's been used and it's been contaminated in some sense, whatever level of treatment that is needed to make it safe before it gets put in whatever storage facility that is. So there's a lot of what ifs that go along that. So again, I think conceptually, great idea. And if we had a safe storage place that you could just send, once used wastewater until you may need it for something else. Again, I think it's a great idea, but you got to think about where, how, and then, the level of treatment that's there.
Yeah, I think I agree with Jason. So in terms of wastewater reuse, there are some areas in the US like Orange County and like Arizona, they're doing indirect and direct potable reuse, putting wastewater directly into managed aquifer recharge because they have advanced treatment. And with that kind of treatment, I think it's possible to, reuse for drinking purpose. But for private wells, I think it's difficult in terms of, putting wastewater for recharge program for private well owners, because you also need to consider their treatment methods. Most of them, they may have septic systems, and they may do the, gray water recharge, separating, but that's also very difficult for homeowners. So I think in terms of cost benefit, it's kind of difficult. And then also in terms of accepting, reusing wastewater, there is a yuck factor. A lot of individuals, they may not want to accept this idea of drinking wastewater, but once you, I think, educate them, maybe they'll be able to do that in the future, because the wastewater is not, direct like fecal contaminated, but it's been treated with advanced treatment and maybe, used for potable purpose.
Thanks, Sam. Thanks, Jason. Jill, did you have any comments?
Sorry, I got distracted for a second. My phone rang about another well program.
No worries. Did you get a chance to hear Alexandra's question?
I did not.
So I hope I can capture this correctly. Alexandra, feel free to jump in and correct me if not. But essentially, she's asking regarding the idea of using wastewater, treated wastewater, to recharge private wells. Has that been done? And are there any recommendations regarding that?
It has been done. I mean, a lot of that, I guess that would be what we would kind of classify as a gray water. And y'all may have already said this, Jason and Sam, but I know a lot of it in some of our bigger cities, instead of that water that's been treated going, doing nothing. I know that some of the golf courses and some of the larger entities like that, football fields and recreational facilities have been moving that water to keep those waters, because a golf course thinks they have to be the greenest place in town. So a lot of that gray type water has been used for keeping those irrigating golf courses and moving it to those locations, because people, as silly as we are, when we start thinking about water that's already been through a treatment plan, we still think it's been through a treatment plan and don't want to drink it. But little do we realize we're probably all victims of it, that it gets pumped from here to there and we're replenishing, reusing all the time, and we just don't realize what's going on with us.
All right, thank you. Alexander, did you have any additional questions?
Not at this time. That should suffice, because of all things, like I said, I mean, of all things, I actually lived in Texas, so there were times, and drought was an issue, and so I can imagine that sometimes it would be nice to actually just be able to have that extra water, even if it was just treated. At least, like I said, it could sometimes be drinkable, better than no water.
True. All right, thank you. Okay, I guess I have a question for the participants. Does anyone want to share any types of partnerships or collaborations that might have been fruitful for them? If you guys are working in private well programs that are addressing impacts of climate change. Does anyone want to share?
Yeah, so in terms of saltwater intrusion, I don't think there are very successful policies or intervention for private well owners to combat saltwater intrusion. I think what I have learned is, it's more, there are policies for farmers using private wells for agriculture. They have some programs from the USDA, like Agricultural Conservation Easement Program, that can, help farmers to adapt their land if they are facing, pressure from saltwater intrusion. USDA, they have several other programs like Conservation Reserve Enhancement Program, where if the farmers, they are having saltwater intrusion problems, they can mitigate. And it's part of the Farm Bill that was introduced 2014, when, the farmers, they can take these kind of programs and then mitigate saltwater intrusion. For private well owners, in terms of potable water for saltwater intrusion, I haven't seen one, because we had a lot of interaction with well owners in the state of Louisiana, and if they were facing saltwater intrusion or any other problems associated with flooding or stuff, there was very limited funding from the state, because it's not regulated. And we applied for other funding, like governmental and also private foundation funding, and worked with a community-based partner, because I think I'm in academia, so the university was very difficult to work with private well owners. So working with a community-based organization like Pontchartrain Conservancy, it helped us to get funding from the EPA or NSF to install some of the RO units in some of these well owners. And they were happy that they were able to afford it, because in a lot of these private well owners, a lot of these options of recharging the wells and the injection well, some of these options are not effective and very expensive. It might be very good for public water system or large city water supplies, but they were happy we were at least able to provide some of these RO units for them. But there's another question, if the providing the equipment is not sufficient, because we need to maintain those over time period, like 5-10 years, we have to keep maintaining it, and we don't know how they will be able to afford to maintaining something like that. So I think there needs to be more funding, even from the state or local level, to help private well owners to combat saltwater intrusion.
Thanks, Sam. All right, I think we've got a question for Dr. Barrett. Laura has a question for you, Jason. What is being done in Mississippi to target vulnerable or underserved populations that rely on private drinking wells? I think she goes on to say, do you have any outreach programs to provide monitoring, screening, and well quality mitigation assistance that proactively, sorry, I kind of lost it. That proactively, gosh, my computer is acting all crazy. I apologize. Do you have outreach programs to provide monitoring, screening, and well quality mediation assistance that proactively address disparities for vulnerable populations such as those with low income, non-white, racial ethnic groups, those that depend on older rather than newer wells, or well water using households who are non-homeowners or renters? So any thoughts on that?
Well, I'll say this, because everything I see Laura, I'm looking in the chat here. I see Laura Merrick's and then Andrew George reply kind of after that. That was one of the pieces that I said, we work through our county extension offices. And I'm gonna say the efforts we made, we did this on the coastal counties, trying to loop in with some of the churches and then also offering it at no cost. And it's so, and that, this is what's wild. And I don't know if it's just this assumption that if it's free, there must be something wrong with it, some catch. Because when we were charging for it, people were coming and participating and getting their well sampled. But, when we started making strong efforts to recruit outside our normal base, that would just be in the loop with whatever the extension office is doing, again, trying to connect with the churches, offering the screenings at no cost, we were getting less participation. We still had a handful, but when I would typically go to a coastal county, I would have 50 well samples and participants come in, and then we started doing it for $0 and I get 15. So it's kind of strange in that regard. Again, we've made I know we made some efforts a handful of years ago because we had a project where we were trying to target lower income, potentially underserved communities. But it's hard. I don't feel like I was able to truly get into that group. But if you heard me also say, I'm really more concerned about the lower income people in Mississippi that are on a public supply but are on septic. Because I really don't think, and I've been around a lot. I was born and raised in Mississippi. Majority of the people that we see that I would say are underserved are on a public water supply. But they're actually on septic, and their septic is, to me, more of an issue than the private well, at least from what I'm seeing. And that's not a blanket statement for everybody, but that margin of our 12% on private wells and 35% on septic tank, that margin in there, that 25% or so, or 20% that are on septic is probably the most vulnerable when we think about underserved minorities. That's the group to me that I see.
All right, thank you, Jason. I think we've addressed all the questions at this point, and I just want to remind folks that we do have 2 learning sessions, the first one taking place on November 9th at 1 p.m. Eastern. I will be sending out a follow-up email to all registrants, highlighting the registration link for both the learning sessions, and we hope to see all of you at each of those. And with that, I think we can go ahead and close out this workshop for today. I want to thank all 3 of our speakers, Dr. Barrett, Mr. Pig, and Dr. Shurchin. Appreciate your guys' time, appreciate all of your insightful presentations. And thank you to all of our attendees for engaging, participating, asking great questions. We really appreciate you, and we hope you will take advantage of the 2 learning sessions that we have coming up. And I do want to remind you to please take the survey. I'm going to go ahead and drop the link to the survey in our chat. It does help us to plan for future trainings, so please do do take that survey. It should take you no more than 2 to 3 minutes. You could also use the QR code if you're more comfortable using your phone and take the survey that way. I've also included my contact information. If you have any questions, please reach out to me. I do expect to get some questions regarding CEs. So if you do have anything on that, please don't hesitate to reach out, and I'd be more than happy to help you. With that, thank you all so much, and see you folks in November.
Bye now.
Bye-bye.